Then the next question, the ratio of secondary to the primary turns in a transformer is 3:2. So NS is to NP, this ratio is given as 3:2. If the power output be P, then the input power neglecting all losses must be equal to. So the ratio of secondary to that of the primary turns in a transformer is 3:2, that is NS upon NP is 3:2. If the output power is P, then the input power neglecting all losses must be equal to. This is the question which is asked in MPPMT in 1984 and KCET in 2003. So since here itself it is given in the problem that neglecting the all losses, it means that this is an ideal transformer. So since it is an ideal transformer, so you know that for ideal transformer output power is exactly equal to that of the input power. So since the output power is P, so the answer is C, that is P. So the input power is also P, since it is the ideal transformer. Then next question, the primary winding of a transformer has 100 turns and its secondary winding has 200 turns. The primary is connected to an AC supply of 120 volt and the current flowing in it is 10 ampere. The voltage and the current in the secondary are. So you have given the number of turns in the primary, that is 100. The number of turns in the secondary winding is given as 200. The primary is connected to an AC voltage supply of 120 volts. So primary input voltage is given as 120 volt and current flowing through it is also given, which is 10 ampere. And now you have to calculate the voltage and current in the secondary coil. So we know that the ratio NS upon NP, that is the transformation ratio, is equal to Vs upon Vp, where Vs is the voltage in the secondary coil and Vp is the voltage in the primary coil. So this ratio Vs, this ratio NS upon NP is 200 divided by 100, and it should be equal to Vs upon Vp, where Vs you have to calculate and Vp is given, which is 120 volt. So this ratio simply is equal to 2, and therefore by cross multiplication we get Vs is equal to 240 volt. So if you look at the options A, B, C, D, so obviously the option C and D, they are not the part of the solution because the voltage is 60 volt and 120 volt. So the answer is between A and B. So now you have to find out the current. So you also know that I have told you that the formula for transformation ratio, which is NS upon NP is equal to Vs upon Vp, and that is equal to Ip upon Is. So this Vs upon Vp is equal to Ip upon Is. So now we can use this ratio Vs upon Vp. We have already find out what is Vs. So this Vs is 240 volt divided by Vp, which is 120 volt. So that ratio is equal to 2, or you can use this ratio also because this is also 2. So this ratio is equal to Ip upon Is. So Ip is given, it is 10 ampere divided by Is. So again cross multiplying we get the current in the secondary coil as Is is equal to 5 ampere. Then next question, a step down transformer is connected to 2400 volts line and 80 amperes of current is found to flow in output load. The ratio of the turns in primary and secondary coil is 20:1. If transformer efficiency is 100%, then the current flowing in the primary coil will be. So you again have to find out what is the current in the primary coil. So now this is the problem which is based on step down transformer. It is connected to 2400 volts line and 80 amperes. So input voltage is given as 2400 volts and input current is given as 80 ampere. Then you have given the ratio of the turns in primary and secondary coil, which is 20:1. If transformer efficiency is 100%, transformer efficiency is given as 100%, then you have to find out the current flowing in the primary coil. Okay, so you know that the transformation ratio NS upon NP is equal to VS upon VP. From this, the transformation ratio is given as 1:20, because the NP upon NS is given as 20:1. It means that NS upon NP is 1/20, and this should be equal to VS upon 2400, because my primary voltage is VP, which is 2400, it is given. So from this, again cross multiplying, we get VS is equal to 120 volt. Then for 100% efficiency, we have seen the formula for efficiency, that it is output power upon input power into 100%. So if the efficiency is 100%, it means that output power is exactly equal to that of the input power. So my output power is VS into IS, that is voltage in the secondary multiplied by current in the secondary coil, and it should be equal to primary voltage multiplied by the primary current. And therefore now we have calculated what is the voltage in the secondary coil, that is 120 volt. So 120 multiplied by 80, that should be equal to 2400 multiplied by IP, because here it is given that 80 amperes of current is found to flow in the output load. So for output current is 80 ampere, 120 volt we have found out already. So 120 into 80, that should be equal to 2400. This is my input voltage multiplied by input current. So again cross multiplying and simplifying, we get IP is equal to 4 amperes. So answer C is the correct option. Then the next question, that is a loss free transformer has 500 turns on its primary winding and 2500 in the secondary. The meters of the secondary indicate 200 volts and 8 amperes. Under these conditions, the voltage and current in the primary is. So again, this is a very simple question. It is a transformer which is a loss free transformer. So it is an ideal transformer. There are no I2R losses in the transformer. Then it has 500 turns on its primary. So NP is given. Then 2500 turns in the secondary. So NS is given. Then the meters of the secondary indicate 200 volts and 8 ampere, means VP and IP is given. VS and IS is given, that is voltage, output voltage and output current are given, and you have to find out the input current and input voltage. So again, by using the transformation ratio, that is VP upon VS is equal to NP upon NS. So 500 divided by 2500, that will be equal to 1/5. So my VP will be equal to 200 divided by 5, that is 40. So if you look at the options, A, B, C, D, then from the options you can see that here there is only one option, which is B, which is having the voltage as 40 volt, while for the rest of the options there is no voltage as 40 volt, which we have calculated. So there is no need to calculate the value of current. Obviously this is the correct answer, which is B. In case if there is another option with the same value of voltage, that is 40 volt and then 10 ampere, then in that case you have to find out the value of IP, and that also we can find out by using the formula of efficiency, because output upon input into 100%, that is called as the efficiency, and since it is the ideal transformer, which is a loss free transformer, it means that output power is exactly equal to the input power, and therefore IP into VP is exactly equal to IS into VS. So from this relation we can find out what is IP, which is equal to IS into VS upon VP. So that is 8 into 5, which is equal to 40 ampere. Then the next question, a transformer is employed to reduce 220 volt to 11 volt. So obviously this is a step down transformer. The primary draws a current of 5 ampere and the secondary 90 ampere. The efficiency of the transformer is. So we have seen the formula for efficiency. It is output power upon input power into 100%. So it is Vs into Is upon Vp into Ip into 100%, which is equal to output voltage is given as 11 volt, and the output current is 90 amperes. So it is Vs into Is, which is 11 into 90 divided by input voltage is 220 volt, and input current is 5 ampere. So it is 220 into 5, that is this ratio. If you calculate this ratio into and multiply it by 100, you will get the answer as 90%. So answer D is the correct one. Then next question, in a step up transformer the turn ratio is 1:2. A Lagrange cell EMF 1.5 volt is connected across the primary. The voltage developed in the secondary would be. So here the ratio of here the transformer is a step up transformer, and the turn ratio is given, which is the transformation ratio, which is 1:2 is given. But if a Lagrange cell of EMF 1.5 volt is connected across the primary, and you have been asked to calculate what is the voltage developed in the secondary coil, but you remember that here this Lagrange cell is a DC voltage, and transformers do not work on the DC, and therefore here the correct option is D, that is 0, because transformers doesn't work on the DC. The next question, the alternating voltage induced in the secondary coil of a transformer is mainly due to. The alternating voltage which is induced in the secondary coil of a transformer is mainly due to, options are A, a varying electric field, a varying magnetic field, the vibrations in the primary coil, and the iron core of the transformer. Now if you see that all of them, they are the component of the transformer's working principle, but the correct option is B, that is a varying magnetic field. So due to the varying magnetic field, if a varying magnetic field is changed in inside the coil 2, that is secondary coil, then it produces the induced EMF. So that is important principle. So here a varying magnetic field is the principle. Then the next question, a 100% efficient transformer has 100 turns in the primary and 25 turns in its secondary coil. If the current in the secondary coil is 4 ampere, then the current in the primary coil is. So for 100% efficient transformer, you again know that output power is exactly equal to the input power. So Vs into Is is equal to Vp into Ip, and therefore Vs upon Vp is equal to Ip upon Is, which is equal to Ns upon Np. So if we substitute this, then we get Ip upon 4 is equal to 25 divided by 100. So we get Ip is equal to 1 ampere. So these are the sort of questions which are asked on this topic of transformer, and therefore if you remember these formulas for the transformation ratio, then you will clearly get 1 to 2 questions from this topic, and which are very simple questions to solve on the transformer. So you remember the transformation ratio and the formula for efficiency. If you like my video, then you can subscribe my channel, you can like and share my video. Thank you.